Your teacher today is Dr. Bosa, Science. Dr. Bosa is a teacher at the Science Foundation College, the best school that teaches sciences. Today we are going to study organic chemistry, lesson 16, Carbonyl compounds, nomenclature, physical properties and chemical properties. Carbonyl compounds are compounds that contain a carbonyl group shown below. They are classified as aldehydes or ketones. Aldehydes are compounds with the following structure, where R is an alkyl group. Nomenclature of aldehydes. Aldehydes are named by replacing the final E of the corresponding alkanes with Al. Since the aldehyde group must be at the end of the chain, its position is not indicated in the name. For example, we have methanol, ethanol or acetaldehyde, propanol or propynyl aldehyde, and then butanol or butyraldehyde. Ketones are compounds with the following structure, where R is an alkyl group. Nomenclature of ketones. 1. Their names end in suffix ONE. 2. The position of the ketone group is given by the lowest number. For example, propanone, butanone, 3-methyl pentane, 2-on. Preparations of carbonyl compounds. A. By oxidation of alcohols. Primary alcohols are oxidized to aldehydes, while secondary alcohols are oxidized to ketones. 2. By hydrolysis of gamma-dihalides. For example, dichloromethylbenzene is hydrolyzed by water to benzaldehyde. Physical properties. A. The polar carbonyl group makes carbonyl compounds polar and therefore have high melting and boiling points than non-polar compounds of similar molecular mass due to formation of intermolecular bonds. B. Lower members are soluble in water due to formation of hydrogen bonds with water, but the solubility decreases with increasing alkyl group length. Chemical properties. 1. Reaction of carbonyl compound with hydrogen cyanide or potassium cyanide. The reaction of hydrogen cyanide is catalyzed by sodium or potassium hydroxide. For example, ethanol reacts with hydrogen cyanide in the presence of potassium hydroxide to form 2-hydroxyl propane nitrate. In the mechanism, hydrogen cyanide reacts with potassium hydroxide to form potassium cyanide and water. Then the cyanide ion donates a pair of electrons to the carbonyl carbon and bonds. The bond between carbon and oxygen atom breaks to form a negative charge on oxygen atom. Addition of water forms 2-hydroxyl propane nitrile. Complete and write mechanism between propanol and potassium cyanide. Solution. Propanol reacts with potassium cyanide to form 2-hydroxyl 2-methyl propane nitrile. In the mechanism, the cyanide ion donates a pair of electrons and bonds with the carbonyl carbon. The bond between the carbonyl carbon and oxygen breaks to form a negatively charged compound. Addition of water forms 2-hydroxyl 2-methyl propane nitrile. B. Reaction of carbonyl compounds with sodium hydrogen sulphite. For example, ethanol reacts with sodium hydrogen sulphite to form a sulphite salt. In the mechanism, exercise, complete and write a mechanism between propanol and sodium hydrogen sulphite. Solution. Propanol reacts with sodium hydrogen sulphite to form a salt, as shown below. The mechanism is as follows. Reaction of carbonyl compounds with ammonium derivatives. Carbonyl compounds react with compounds with the general formula H2NY with elimination of water. The reaction is catalyzed by an acid as follows. In the mechanism, the compounds formed are colored between yellow and orange, and therefore ammonium derivatives such as 2,4-dinitrophenylhydrazine is used to identify carbonyl compounds. When acidified solution of 2,4-dinitrophenylhydrazine is added to a compound and a yellow precipitate is formed, then that compound is a carbonyl compound. Examples of ammonium derivatives. Exercise 1. Complete and write a mechanism between ethanol and phenylhydrazine. Solution. Ethanol reacts with phenylhydrazine in the presence of an acid to form the product. The mechanism is as follows. Complete and write a mechanism between propanone and 2,4-dinitrophenylhydrazine. Solution. Propanone reacts with 2,4-dinitrophenylhydrazine to form the product. The mechanism is as follows. Reduction of carbonyl compounds. Aldehydes are reduced by lithium aluminium hydride in the presence of dry ether or hydrogen in the presence of nickel to form primary alcohols, while ketones are reduced to secondary alcohols. Aldo condensation. Carbonyl compounds which contain at least one alpha hydrogen react in the presence of alkali to form compounds called aldos. Alpha hydrogens are halogen atoms on carbon atoms next to carbonyl group as shown below. Two molecules of ethanol combine to form phenylhydroxyl butanol as shown below. When phenylhydroxyl butanol is warmed, it forms but2-enol or chlorotanaldehyde. The mechanism is as below. Ensure that all negative charges are accounted for. Complete and write a mechanism for the reaction between propanone and an alkali. You can pause and answer. Two propanone molecules combine in the presence of an alkali to form 4-hydroxyl 4-methyl pentane 2-on. The mechanism is as follows. Cannizaro reaction. This is a reaction between sodium hydroxide solution and aldehydes with no alpha hydrogen. It is a self-oxidation reduction reaction. For example, methanol reacts with an alkali at 150 degrees to form methanol and methanoate ion. Benzaldehydes reacts with an alkali to form phenylmethanol and benzoate ion. The mechanism is as follows. Iodoform reaction. Iodine in the presence of sodium hydroxide reacts with carbonyl compounds that contain a methyl ketone to form a yellow ppt. For example, a methyl ketone plus iodine in presence of sodium hydroxide, you get a carboxylate salt and a yellow ppt of triiodomethane. Note that iodine in the presence of an alkali is used to identify compounds with a methyl ketone group. 2. Ethanol is only aldehyde that give a positive iodoform test. Ketones with the structure RCOCH3 give positive iodoform test. Second, alcohols with a hydroxyl group on position 2 give positive iodoform test. 5. Ethanol is the only primary alcohol that gives a positive iodoform test. Exercise. Give one reagent that can be used to distinguish between the following pair of compounds. In each case, state what is observed. 1. Methanol and ethanol. The reagent is iodine in the presence of sodium hydroxide. Ethanol gives a yellow ppt while methanol does not. 2. Methanol and ethanol. The reagent is iodine in the presence of sodium hydroxide. Ethanol gives a yellow ppt, methanol does not. 3. Pentane 2 on and pentane 3 on. The reagent is iodine in the presence of sodium hydroxide. Pentane 2 non gives a yellow ppt, whereas pentane 3 non does not. Oxidation of carbonyl compounds. Aldehydes are oxidized by weak oxidizing agents to carboxylic acids, while ketones are not. So oxidation of aldehydes by weak oxidizing agent is used to distinguish aldehydes from ketones as below.